Hello everyone, today we are going to look at Form 4 Additional Maths Chapter 3 System of Equations, and we start off with 3.1 System of Linear Equations in 3 Variables. So before we start, we try to do a bit of revision on linear equations in 2 variables, which you have already learned in Mathematics Form 1. So in this part, you learn that the general form of linear equation in 2 variables can be shown in this form, where a, b, and c are constants and x and y are variables. This is a linear equation because the highest degree of the variables x and y is 1. The examples for this are 2x plus 3y equals to 7, or negative 4x plus 5y minus 3 equals to 0. A linear equation can be shown in the form of graph. Like for example, if we have a linear equation here, 2x plus y equals to 4, we can plot this by first drawing a table. We fill in the values of x to find the value of y. Then we plot the graph. When we plot, we will form a straight line. So this straight line represents the linear equation of 2x plus y equals to 4. Now we come to the linear equation in 3 variables, which can be written in the general form of ax plus by plus cz equals to d. Notice that the variables here are x, y, and z, where a, b, c, and d are constants and they cannot be 0. Examples are like 2x plus 3y minus 7z equals to 1, negative 4x plus 5y minus 3z equals to 0. And what will happen when we try to plot this? Since there are 3 variables, when we are plotting this, there must be 3 axes. Like for example this, the x-axis, y-axis, and z-axis. And we try to plot it, we will form a plane. So let me try to show you by using this application, online application, where now we have the 3 axes. The green, red, and blue, which represents the x-axis, y-axis, and z-axis. So when we try to plot this, 2x plus 4y minus z equals to 10, we will form a plane such as this. You can see that the plane is represented by the blue color, and the plane is somewhat like a very thin piece of paper. So this is in the 3-dimensional form. Every point on this plane has an x value, y value, and a z value which satisfy this equation. So in short, a linear equation in 3 variables can be shown by using a plane such as this. Now we come back to a system of linear equations in 3 variables. So when we are discussing a system of linear equations, there are actually 3 equations where each equation has the same 3 variables as shown here: x, y, and z, x, y, and z, x, y, and z. All 3 equations have the same variables, and all of these are linear. Hence, this is a system of linear equations in 3 variables. So let me show you some more examples by using this exercise. Form a linear equation in 3 variables for the following statement. So now if you are given a statement, Ali bought 8 pens, 10 pencils, and 2 rulers for a total of 9 ringgit. We can actually write this statement in the form of linear equation in 3 variables. So the 3 variables are the number of pens, the number of pencils, and the number of rulers, which we use x, y, and z to represent each of these. Hence the answer will be 8x, because x is the number of pens, 10y, and 2z equals to 9. And the second part is identify whether the following equations are systems of linear equations in 3 variables or not. So you are now given a set of 3 equations. We try to determine whether they are a system of linear equations. So we need to check whether all the variables here is linear, means the highest degree is 1. You see x highest degree is 1, y highest degree is 1, z 1. So all three of these are linear equations of three variables, hence this is a system of linear equations in three variables. So try to look at the next one. M, degree 1, degree 1, degree 1. Since all three of these are linear equations in three variables, hence this is a system of linear equations in three variables. The third example here, so it's quite obvious here, you can see that y has a power of 2. Hence, the highest degree of y is to the degree of 2. Meaning that this is not a system of linear equations in three variables because one of the variables has the degree of 2. Now we come to solving problems of linear equations in three variables. So when we are solving the system of linear equations, what we are doing is we find the values of x, y, and z which satisfies all three of the equations. The same value which satisfy all three of the equation. So when we are solving this, we will find that there are different types of solutions, different types of the possible answers. Okay, so we look at the first type. The first type, you'll get one solution. Meaning that when you are given a system of linear equation in three variables, when you solve it, you will get one set of answers. One solution here means there is only one set of possible answers. Means x must be 15, y must be 120, z must be 45, and all these three values satisfy all three of this equation. There is only one possible set of answers. And if we try to show this in the form of a graph, remember that each linear equation here forms a plane. And when there are three equations, means you form three planes. Now we try to come back to this application again, where there are three axes. And the three equations are 3x minus y minus z, the same equation shown just now with one set of answers, one solution. And if you try to plot this onto this Cartesian plan, we will form the first equation will form the first plane, which is shown by this blue colored plane. The second equation, when we plot it, we will have this red colored plane. Notice that the two planes intersect each other along this line. And the third equation, when we plot it, will form the third plane which intersects the blue plane and the red plane. And you will notice that these three planes, the blue, red, and green, which represents these three equations, they will intersect at one point, this point here. The blue, green, and red will intersect at this point. You can see. Okay, I turn it around so you can see that all three of these planes passes through this point. Hence, this point here is actually the solution. Since there is only one intersection point, there is one solution. So this point here represents the one and only one set of solution, which is x equals to 15, y 120, and z 45. And the conclusion here is, when a system of linear equation has only one solution, the three planes formed from these three equations intersects at one point, which is this point. Now, how about the second type? The second type is the type of solution where we have infinite solution. Infinite solution here roughly means that there are unlimited answers. There are unlimited number of answers to the system of linear equation. And if you try to show this in the form of graph, the three planes intersect along a straight line. So when they intersect, this purple, blue, and red plane, when they intersect, they will intersect along this line. And hence, any point along this line will be the answer which satisfy all these equations. Then the last type, the third type, is no solution. So no solution means there is no one set of answer which satisfy all three equations. And in the form of graph, the planes do not intersect at any point. For example, you see the purple and the blue, they only intersect along this line. Whereas the red and the purple, they intersect, but there's no intersection point between the three lines altogether. Now we're done with the concept part. We now try to learn how to solve when you are given a system of linear equations in three variables. So there are two methods. First is substitution method. The second is elimination method. So we try to look at the first method. We solve the following system by using the substitution method. So now we have the three equations over here where we label it as equation number 1, number 2, and number 3. Notice that all these equations have the same variables, which is x, y, and z. Now we take equation number 1, 4x minus 3y plus z equals to negative 10. And we try to pick a variable, either x, y, or z, as a subject. So here we take z as a subject. And we move x and y to the right hand side. And then we label this as equation number 4. Now we pick any one of these 2 or 3 equations, and then we substitute 4 into the equation. So now we try to substitute equation number 4 into equation number 2. So the z here now is replaced with negative 10 minus 4x plus 3y, which is equals to 0. Now we simplify this by dividing by 10, negative x plus y minus 3 equals to 0. Now we have two variables left, and we take one, let's say y, as a subject again, and move the rest to the right hand side. Then we label this as equation number 5. Now we substitute equation 4 and equation 5 into equation number 3. So substitute equation 4 and equation 5 into equation 3. So this equation, we write this down, negative x plus 2y minus 5, and the z here is being replaced by equation 4, which is negative 10 minus 4x plus 3y equals to 17. Now we simplify this. We still have two variables left, x and y. So we try to substitute 5, equation number 5, y equals to 3 plus x into the y. And now we only have one variable left, which is x. Then we solve it. We get x equals to 1. Now we substitute x equals to 1 into equation number 5 to find y. We will get y equals to 3 plus 1 equals to 4. Now we have x and y. We still have to find z. So we can substitute into any equations 1 to 4, and the easiest one will be equation number 4 because z is already the subject. So we just replace the values, substitute the values to find the value of z, which is negative 2. So we rewrite all the answers, and that's the first method. Since we already learned the substitution method, we look at the second method, which is elimination method. Again, we use the same system of linear equation of three variables, but now we are using the elimination method. So now we have another three equations. Actually, they are the same equation, and we label the first one as equation number 1, the second one as equation number 2. So if you want to use elimination method, we need to eliminate one of the variables from these first two equations. We can either use multiply or division to help us. So we pick any one of the variables here. Let's say we pick a variable x, and we try to make the coefficient the same. So 4x and 2x, so we try to, from the equation number 2, we multiply 2 to every terms in equation number 2. So we will get this equation, and we label it as equation number 3. And if we compare with equation 3 to equation 1, the coefficient of the variable x is the same now. So we can get rid of 4x by equation 1 minus equation 3. 4x will minus 4x, and you get 0. Negative 3y will minus with positive 2y. So you just write negative 5y. Positive z minus positive 6z, you will get negative 5z. And negative 10 minus with 0, you get negative 10. And now we try to simplify this by dividing the whole equation with negative 5. So you get y plus z equals to 2. And you label this as equation number 4. Now we take the next two equation 2 and the third one, and we label this as equation number 5. So from these two equations, where they have the same variables, so we try to get rid of the x variable as what we tried in the first step. So equation 5 times 2 becomes negative 2x plus 4y minus 10z equals to 34. And so we label this as equation number 6. So now the coefficient is 2 and negative 2. So to get rid of this variable, we add equation 2 to equation 6, so that 2x minus 2x equals to 0. So 2 plus 6, equation 2 plus equation 6, 2x plus negative 2x equals to 0, and y plus 4y equals to 5y, 3z plus negative 10z equals to negative 7z equals to 34. And we label this as equation number 7. So now we have two equations with two variables y and z, and we try to solve these two equations as simultaneous linear equation with two variables. So from 4, we take y as a subject, we let y equals to 2 minus z from equation 4, and then we substitute this into equation number 7. So now equation number 7, the y becomes a 2 minus z, and we manage to get rid of the variable y, and now we only have variable z. And after that, we try to simplify the equations to find the value of z. So z equals to -2. Now we substitute z equals to -2 into the previous equation here in order to find the value of y. So y equals to 2 plus 4. 2 plus 2 equals to 4. And now from the value of z and y, we can take any equation here. We replace, so we take the first equation and we replace the y with 4 and the z with -2. From here we can find the value of x. Then we restate all the answers. And that is how you use the elimination method. So from the previous part, we get to find one solution for the given system of linear equation. So how about solving system of linear equations in 3 variables when there is no solution or when there are infinite solutions? Let me show you. So now here we have the 3 equations we label as equation 1 and 2. We try to use elimination method to get rid of the variable x. So we let equation 1 times 2 so that it has a coefficient of 2, becomes 4y minus 6z equals to 44. We then label this as equation number 3. So now by comparing equation 3 and 2, we can get rid of a variable x by adding up -2 and 2. So 2 plus equation 2 plus equation 3, the -2x plus 2x cancel off each other, becomes 0. -4y plus 4y, you have 0, plus 6z plus -6z, you get 0 again. -34 plus 44, you get 10. Hence 0 equals to 10. But 0 cannot be 10. So this implies that there is no solution for this system of linear equations in 3 variables. Next question. We have a new equation where we label as equation 1 and equation 2. We try to get rid of variable z. So that's why equation 1 we need to multiply with 6. So we have 12x plus 30y minus 6z equals to -9. We can eliminate z because it has a positive 6 and -6. So we just add equation 2 and 3. 3x plus 12x, we get 15x. -4y plus 30y, you have positive 26y. Positive 6z minus 6z, you get 0. -9. And here I think I made a mistake. The previous -9 is supposed to be -54. So I continue, -9 here plus -54, I get -63. And now I label this as equation number 4, and we have ourselves a new equation with only x and y variable. And our next step is to come up with another new equation with only x and y variable. So now I take another 2 equations, let's say equation 1 and the third one, which I label as equation number 5, in order to get rid of to eliminate z easily. So 1 plus 5, equation 1 plus equation 5, I get 2x plus -17x, I get -15x, 5y plus -31y, I get -26y, -z plus z equals to 0, and -9 plus 72, I get 63, which I label as equation number 6. So we have another new equation with only variables x and y. Equation 4 here comes from equation 1 and 2, whereas equation 6 comes from equation 1 and 5. So what will happen when we try to eliminate one of the variable? So we try 4 plus 6. 4 plus 6, since 15x minus 15x will get 0, 26y minus 26y 0, negative 63 plus 63 gets 0. So when you add them out, you get 0 equals to 0. So this implies that there are infinite solutions. So these two examples shows us that when solving a system of linear equations, you might face no solutions and infinite solutions. So this is the first part of the video. Thank you for watching.